Next exercise 7, question number 1. Mai commutes to work 5 days a week on a train. She does 2 journeys a day over a long period of time. She finds the train is late for 20% of the time. So the P is according to the history, that is going to be 20%, that is going to be zero point 0.2. A new company take over, then uh, take over train service. My users might think that the service should be late more often. In the first week, it means late more often. It means this is the probability of getting late. It's more often mean it is more than this probability. It means probability of greater than zero point 0.2. So it's look like it's going to be one tail test. She give the direction that probability is increased. That is a feeling. Uh, in the first week, new service, the train is late 3 times. So x is 3, and number of trial is she is working 5 days and 2 days per 2 journey per day. So it is going to be 10. So have it. Those are the information we have now. So we have to define all the variables. It says number of occasions the train is late. If we use P, it is the probability of the train is getting late. Train is getting late, and x follow binomial 10 p. So h naught is p equal 0.2, and h1 is p greater than 0.2. If h naught is true, then x should follow binomial 10 0.2. So it's going to be 5% significance level. So x equal 3 is observed value. So probability of x greater than or equal to 3 is 1 minus probability of x less than or equal to 2. So we can get this one from the table, and this is going to be 1 minus 0.6678. This value is 0.322 less than greater than 0.05. So now the conclusion is, hence observed value does not lie in the critical region, hence there is no sufficient evidence reject So this is accept. Accept mean no reject. Reject null hypothesis. Hence, there is no evidence that the train are late more often. Question number two. Two type of cheddars, Chesley cheddar and the other type, and if they have the same popularity, equal popular preferences, then probability has to be 0.5 or 1 half. But they believe one is more than Chesley cheddar is better than the other cheese. It means that probability is more than 0.5. So that is their belief. It's going to be one tail look like. They select 5 people and n equal 5, and the observation, the 4 people say that they prefer Chesley. So um, X. The variable is number of people who prefer Chesley cheddar, and P probability of number of people who prefer Chesley cheddar. And X-Palo binomial 0.5. So H naught P equals 0.5. So equal preferences. Oh, but they are claiming Chesley is better than 0.5. So this is a one-tail test. If H naught is true, X should follow binomial 5 0.5. So X equal 4 is the observed value. So significance level is given 5%. So probability of X greater than or equal to 4 is 1 minus probability X less than or equal to 3. That is 1 minus 0.8125. This is going to be 0.1875. 5% means 0.05. So this is greater than 0.05. Hence, observed value. So basically, this is acceptance. So having that idea, the observed value does not lie in the critical region. Hence, there is no sufficient evident to reject H naught. Hence, there is no sufficient evidence that the Chesley cheddar is better than common cheddar. Question number 3. Historical information find that nationally 30% of the cars fail the brake test. So B is 30%. 30% is failing the brake test, 0.3. Part A, give a reason to support that the binomial as a suitable model for this. So to have a binomial, we should have fixed number of trials, which we can make it from here. Fixed number of trials. Two possible outcomes. Two possible outcome, pass and fail. And the probability is fixed. Fixed probability. And trials are independent. The one brake system of one car not depend on the other. Trials are independent. And part B. Part B is find the probability that of 5 cars taking the test, all of them passes the brake test. So 5 cars, 1, 2, 3, 4, 5. Assume 2 of them passes the test. Then it can be this one, and not this. So it can be this one, and this one. So other option, this one, if this is 2. So now everything, all the cars pass the brake test. In that case, this is going to be 5C5. And so no failings, 0.3. So this is failing rate 0.3. So passing rate is 0.7. So 0.3 no failing, and all 5 are pass. Or we can write like this as well. And all 5 and no failing, 0. So this is answer is 1. 1 times 0.7 to the power of 5 times 1. 0.16807. So part C is the garage decide to conduct a survey of their cars. A randomly selected sample of 10 of their cars is tested. 2 of them fail the test. So failing is 0.03 probability, 10 cars tested, and the observed value is 2. 2 are failing, and we want to check with the 5% significance level. So now their claim is that the car in this garage failed less than the national average. So this national average is 0.3. It means it is less than the national average. It means it is going to be a one tail test lower bound. Then X is number of cars failing a brake test. P probability of number of cars failing brake test. X follow binomial, so 10 and P. So H naught is P equal to 0.3 according to the national, but this garage believe this has to be less than H1, less than 0.3. So if H naught is true, then this variable should follow the distribution with 0.3. Observe value x equal to and significance level is 5%. Probability of x less than or equal to 2 is going to be 0.3828, which is greater than 0.05. Hence, the observed value x equal to does not lie in the critical region. Hence, there is no sufficient evidence reject the reject the H naught. Hence, there is no evidence that the garage fails fewer than the national average. And question number 4. The proportion of a defective article in a certain manufacturing process has been found from the long experience to be 0.1. So defective article, so this is a population data, P equals 0.1. So this is number of defective articles. A random sample of 50 was taken, and number of defective articles were recorded. Part A, Using 5% significance level, find the critical region for two-tailed test. Hypothesis that 1 in 10 articles has defect. Probability in each tail should be as near as 2.5. So first of all, we need to find the critical region. In the part A, that they are explaining that 1 in 10 article has defected. So 1 in 10 article has defected means the same population, this one 0.1. So instead of telling that they are taking from the same, consider the same probability, they will tell 1 in 10. This information will confuse you for some student to take n equal 50 and x equal 1, which is, sorry, n equal 10 and x equal 1, which is not the information given. So for that you should have kind of a good understanding of the topic to avoid these kind of errors happening. X is the number of defective articles. Is the probability of number of defective articles. So x follow binomial 50p. So h naught p equals 0.1, and this is going to be a two-tailed test. So h1 not p not equal to 0.1, and if h naught is true, then x follow binomial 50 0.1, and rejection region we need to find. So significance level is 5%. It means lower tail near 2.5 and upper tail near 2.5%. We'll start from here. Lower tail, probability of x less than or equal to 0, which is equal to 0. There is no less, there is no minus, so this is going to be 0.0052. So this value is less than 0.025, and probability of x less than or equal to 1 is 0.0338. This is greater than 0.03025. But this value is closer to 0.025, then the critical value is x equal 1. So critical region is x equals 0 and 1. Or we can write 0 greater than x greater than or equal to 1. So for upper tail, so when we start with 9, 10, 11, 8, so we are measuring from here. So up to 10, probability of x greater than or equal to 10 is 1 minus probability of x less than or equal to 9. So that is going to be 1 minus 0.9755, that is 0.7 0.0245, that is less than 0.025, and then we'll go further. X up to here now, x less greater than or equal to 9, 1 minus b, x less greater than or equal to 8. So 1 minus 0.9421, that is 0.0579, greater than 0.25. And when you look at this one is clearly closer to 0.025, hence critical value x equal 10, simple x equal 10. Then the critical region for upper tail is 10 greater than or equal to x greater than 50. Then for this test, the critical regions we can write x less than or equal to and 10 greater than x greater than or equal to 50. Okay, we'll write this one as well. The actual significance level part B is asking actual significance level. So given 5%, the actual one is, we take this one, 0.0338 plus we took this one 0.0245, which is 0.0583 equal 5.83. Part C, now it is a different sum. They are referring the same population. They are referring the same population, but n value is now 20, because another sample 20 articles taken later, 4 articles were found to be detective. So x value is 4 now, and we want to the 10% significance level, and we want to test that this article, 40 articles has increased. It means this is going to be one tail. Increase means it's going to be upper tail. X follow binomial 20p. So H naught is p equals 0.1 and h1 is p greater than 0.1. If h naught is true, x follow binomial 20 0.1. So observed value x equal 4. So probability of x greater than or equal to 4 is 1 minus probability of x less than or equal to 3, that is 1 minus 0.8670, which is 0.133. So this is greater than 0.1. Hence we accept H naught and reject this one. So hence observed value does not lie in the critical region. Hence, there is no sufficient evidence to reject H naught. Hence, there is no evidence that the proportion of defective articles has increased. Question number 5 is claimed that 50% of women use Oriel's powder. P is 50% mean 0.5 probability. In a random survey of 20 women, n equal 20, and 12 said that they did not use Oriel powders. Test the 5% significance level. Whether or not it means it's going to be 210, whether not equal to 0.5. Stay your hypothesis. X is the number of women use Oriel powder. P is the probability of number of women probability of woman use Oriel's powder X follow binomial 20 H naught P equals 0.5 and H1 P not equal to 0.5. If H naught is true, X follow binomial 20 0.5. Observed value is X equal 8 and expected value in P 20 times half, which is 10, or 8 less than 10. Hence lower tail is tested or used for the calculation. So probability of X less than or equal to 8 is 0.2517. That is greater than 0.025. Hence, there is no sufficient evidence to reject H naught. Hence, there is no sufficient evidence to reject that the that 50% of women use Oriel powder. Question number 6. This is regarding the computer, particular type of computer purchase. The history is given. The population parameter is as a proportion is given 0.2 in normal. So P is 0.2, and they tested the number of 50 people 50. So they want to test that probability of different from 0.2. So P not equal to different, it can be low, but it is going to be 2 tail, and should be each tail. So each tail 2.5, it means this is 5%, each tail 2.5. So the X is the test statistics number of computer purchased, and P probability of computer purchased. X follow binomial 50 P. H naught P equals 0.5, and H1 probability is not equal to 0.2. If H naught is true, X follow binomial 50 0.2. So we need to find the critical region. So probability of less than or equal C1 has to be less than 0.025, and probability of greater than or equal to C2 has to be less than 0.25. Now from lower tail, probability of x less than or equal to 4 is 0.1 0185, that is less than 0.025. Probability of x less than or equal to 5 is going to be 0.0480, that is greater than 0.025. So those are the boundaries, and we can see this is much closer to 0.025. Hence critical value C1 is going to be 4. Then upper tail, probability of x greater than or equal to 7 is 1 minus probability x less than or equal to 16. This is going to be 1 minus 0.9856, which is 0.0144. This is less than 0.025. Then we'll go one more lower, 16, that is one probability of less than or equal to 15. 1 minus 0.9692 equals 0.308. So this is greater than 0.025, but this one is closer to 0.025. So then the critical value C2 is going to be 16. Hence the critical region is going to be x less than or equal to 4 and x greater than or equal to 16. So part B, actual significance level. actual significance level is going to be 0.0185 plus 0.0308, so that is going to be 0.0493, which is 4.93 as a percentage. So x is 15, the observed value, hence observed value does not lie in the critical region, hence there is no sufficient evidence to reject H naught, hence there is no evidence to suggest that the proportion of people buying that certain make of computer differ from 0.2. Question number 8. What is hypothesis test? Hypothesis is a statement made about the value of the parameters. So we know that it is the population data. We discussed this one. It can be a mean. So mean mu, or it can be a proportion coming as probability. So we are using in this one all the probabilities in binomials. But when we start doing normal distribution with the hypothesis, is going to be a mean. So those are population parameters. It is a data that represent all the population. When you tell mean, it will represent all the population. If you tell the proportion or the probability, so it also refer all the population. So in previous example, that 0.2, the proportion of people taking a particular computer. So it is a parameter. So it is the hypothesis about a parameter statement we write about that parameter. In hypothesis testing, when we have that kind of hypothesis, then we take a sample, 5 out of 10 people, or 3 out of, we'll take a observed value. Hypothesis use a sample or an experiment to determine whether or not to reject the hypothesis. That's what we were doing in previous exercise. The critical value, the first value to fall inside of the critical region, is the region where we accept null hypothesis, the accept region. In this example, proportion of late or proportion is the parameter. Using proportion, you can transmit information about the population. So now here, the lateness or the computer, number of computer purchase, or the cheese, favorite cheese. John believes that probability of him being late to school is 0.2. To test the claim, he counts a number of Time-elate random sample of 20 n equal 20 and find the critical region for two tails, the 10% significance level, whether the probabilities uh, late for school is differ from, it means be not equal to, so this is going to be two tail test. So x is going to be number of lakes, is the probability of number of lakes. So x follow binomial 20 0.2. H naught is probability of this is equal to 0.2 and H is not equal to 0.2. If H naught is true, x follow binomial 20 0.2. So now we have to write the critical region of probability of S less than or equal to C1 has to be less than 0.025, 0.05 actually, because 10%, and probability of x greater than C2 is less than 0.05. So lower tail probability of x equals 0 is 0.0115 less than 0.05, and x equal greater than or equal to 1, that is going to be 0.692, that is greater than 0.5. So we stay with this one because there is no instructions given to close it. So C1 is going to be 0, and upper tail is probability of x greater than or equal to 8, 1 minus probability x less than or equal to 7 is going to be 1 minus 0.9679 or to 1, that is less than 0. Then I will go one more below x less than or equal to 7. This is going to be 1 minus probability x less than or equal to 6. 1 minus 0.9133, that is going to be 0.0978 greater than 0.05. So C2 is going to be 8. So the rejection region is going to be x equals 0 and x greater than or equal to 8. So part C, actual significance level. 0.0115 plus 0.0321, that is 0.436, that is 4.036. So part D is there's observed value x equals 7. So observed value does not lies in the critical region, hence there is no enough or sufficient evidence just to reject H naught, hence the proportion of times that John is late for school has not changed. Question number 8, it is about the rain story. From large dataset likelihood that with either zero or trace amount of rain in June 19 is 0.05. So P is 0.05, N is 30, and we can see that X equal 21, and we have to test this with the 5% significance levels and increase. So P equal 0.5. So having this knowledge, so X is going to be the number of days with the zero, number of days with either zero or trace of rain, and P is probability of either zero or trace of rain. X follow binomial 30P as usual. So H naught is P equals 0.5 and H1 null hypothesis P greater than 0.5. So if H naught is true, then X follow binomial 30 0.5. X equal 20 is the observed value. Probability of X less greater than or equal to 21 is probability of X less than or equal to 20, that is 1 minus is 0.0214, that is less than 0.05. Hence observed value X equal 21 lies in the critical region. Hence there is no sufficient evidence to reject accept H naught. Hence there is evidence that the likelihood of rain-free day in 2015 has increased. Question number 9. X P is the probability of success. So X follow binomial 30P. H naught is given P equals 0.35 and H1 is P not equal to 0.35. If H0 is true, X follow binomial 30, 0.35. So we had to find the critical region part A. So significance level 5%, it means 2.5 closer to each. Probability of X less than or equal to C1 less than actually closer to 2.5, and probability X greater than or equal to C1 closer to 2.5. Now lower tail, probability of X less than or equal to 5 is 0.0233 less than 0.025, and we can go further. X less than or equal to 6, 0.0586. Now this is greater than 0.025. Now the direction is given to select the closer one. So closer one is this. Then C1 is going to be 5. And for upper tail, probability of X greater than or equal to 17 is 1 minus S less than or equal to 16. So this is the guessings, possible guessings. So 1 minus 0.9876, which is 0.0124, and probability of X less than or equal to 16, that is 1 minus probability of, so this is less than 0.025. We'll go further. X less than or equal to 15, 1 minus 0.9699, which is 0.0301. This is greater than 0.25. Now this is actually much closer. This is closer to 0.025 with the given instruction. So C2 equals 16, and the critical region going to be X less than or equal to 5 and X greater than or equal to 16, and actual significance level is 0.0233 plus 0.0301 makes 0.0534, which is 5.34%. So part C, X equal 4, observed value lies in the critical region, hence there is no sufficient evidence to accept H0. Hence P is greater than 0.3 not equal to 0.35. The pharmaceutical company, question number 10, claimed that 85% of the patients suffering from the chronic rash recover. Chronic rash recover when treated with a new ointment. 20 people was taken for the sample. So the X variable is number of people recover from rash due to new ointment. P is probability of people recover from rash due to new ointment. Probability of people, and X follow binomial 20p. If so in part A we want to find exactly and part B, so part A when P equals 0.85, X follow binomial 20 0.85, and part B exactly 16% patient. So this is probability of X equals 16 is 20 C 16 0.85 16, and 1 minus 0.85 is going to be addition has to be 4. So this is going to be 2016 0.8516 0.154. So you can get from the calculator, which is 0.18. Part C, the next part, the hospital believes that the claim is incorrect. The percentage will recover is lower, so it is lower tail. From the records and administered took a random sample of 30 patients who had been prescribed the ointment. She found 20 had recovered. So then it is look like a new sum again. Now instead of 20, this is going to be 30. H0 is P equals 0.85 and H1 is P less than 0.85. So we have to test with the 5% significance level. If H0 is true, then X follow binomial 30 0.85. Now significance level is 5%. Observe value X equal 21. So probability of X, so it is 20. X less than or equal to 20 is going to be, this is 0.00096. 5 less than 0.05. Hence observed value is The value x equal 20 lies in the critical region, hence there is no sufficient evidence to accept H naught. Hence, recovering percentage of ointment is lower than 0.85 or 85%.